Hi, my name is Fighter Strickland. I'm a PhD student here at UTSA, University of Texas San Antonio. And today I'm going to be showing you Newton's Cradle, which is a good representation of collisions. And we're going to go over inelastic versus elastic collisions and some other forces that are going to be at play. But first, kind of going over how it's set up. We have strings and you just have these little balls here. And there are different things that are going to be at play. So first I want to talk about potential versus kinetic energy. When you have an object at rest that is elevated from the ground or at a specific angle from a string, this is potential energy. It doesn't have any actual motion, but there is potential for energy to be observed once this ball is released from its position. Once the ball is released, this potential energy is going to turn into kinetic energy, and that kinetic energy is going to be distributed throughout this row of beads, and it's going to go from kinetic to potential to kinetic to potential. So the very brief moment where it stops and comes back, it's going to hit potential again. Very, very brief moment when it's here and this ball goes over, you'll have your change kinetic to potential. Now, inelastic versus elastic collisions. Elastic collisions are collisions where the amount of kinetic energy after the collision is equal to the amount of energy before the collision. This is supposed to represent a elastic collision, but in reality, it's not elastic, it's inelastic, where the amount of energy after is less than the amount of energy before. As you can see here, you start off, it looks like it's about the same. Over time, the distance that it ejects out is going to very slowly get smaller and smaller and smaller, and then eventually it's going to stop. That's because in this system, energy is not perfectly conserved, which means there's not an even distribution of energy back and forth. Energy is lost due to sound, friction, heat, air resistance, gravity, things like that, that is making this eventually slow down. But this is about pretty close as we can get realistically. And so that's pretty much Newton's Cradle in a nutshell. Just conservation of momentum, conservation of energy, inelastic collisions, and then the rest of it is pretty much just having fun with the different patterns you can make. And what you can also do is just, the whole thing moves. And so that's going to be the demo. And I appreciate you guys for watching. Catch you guys next time.